Now let's look at our enrolled in relation. Recall that it relates students to the classes that they're taking. And that lets us do one step. Now let's consider what's the inverse of enrolled in. Enrolled in maps from students to classes. For example, relates Carrie to 52665. What about the other way? The inverse relates classes to students, and a class is related to a particular student just in case that student is in fact in the class. Note that the definition, I've written it exactly the same, but I wrote the letters in the opposite order. So this relates classes to students, this relates students to classes. And so we get elements in this inverse relation. For example, 52665 relates to Carrie. All right, suppose we want to now relate students who share a common class. Can we do that using what we've got? We can relate students to classes using enrolled in, and then we need to keep going from classes back to students, which we can do with enrolled in inverse. So let's see how we write that. We start students to classes with enrolled in, and now we need to take classes, come over here and do the next step, which is enrolled in inverse, and that gets us to students. So we write what we need this way: enrolled in inverse composed with enrollment. Let's just quickly see how this works. So suppose this is a tiny piece of our database. So Carrie is related to 52665. Let's look at what elements we get out of this composed relation. So Carrie is related to 52665. The inverse is going to take 52665 back to Carrie, and it's also going to take 52665 to Jerry and to Perry. And so the composed relation is going to take Carrie to 52665 to Jerry, and thus produce the element Carrie, Jerry, which we can write over there. Now we can do this for all the other combinations. It's going to relate Carrie to Perry. And it's going to relate, say, Perry to Jerry, Perry to 52665, and 52665 back to Jerry. There you go. Note one interesting thing. Carrie relates to 52665, which in turn relates back to Carrie. So we can get elements like this: Carrie to 52665 back to him or herself, and we get Carrie relating to Carrie. This makes sense, right? Everybody is in a class with themselves. Now let's go the other way. Suppose we want to relate classes that share a common student. For example, such pairs of classes cannot have their final exam at the same time. So we've still got enrolled in and enrolled in inverse to work with. So what do? This time what we're going to do is we're going to start with a class and map to a student, and then we'll take the student, come back, and go the other way, students to classes. We do enrolled in inverse first, and then enrolled in, because we want to start with classes. So we write it this way: enrolled in composed with enrolled in inverse. And just quickly to run through the examples again, here's the little piece of the database that we've got. Let's see what we get now when we apply these relations in the opposite order. We're going to get elements like this. So 52665 relates to Carrie, and then using the inverse, Carrie relates to 53876. So 52665 relates to 53876, and so forth. And again, just to remind ourselves, since 52665 relates to Carrie and Carrie relates to 52665, we will get all of these elements where a class relates to itself.